I would like to introduce Oli Lane. He's a software engineer at Gearset. Yes, the leading DevOps platform for Salesforce. He's been building SaaS tools in the DevOps space for 6 years and mainly on a .NET stack. Today, he'll be speaking about seamless migrations, a story about upgrading to React. Also, don't forget that if you have any questions at all, please make sure to add them to the chat. And without any further ado, Oli Lane, welcome. How are you?
Yeah, I'm good, thanks. How are you?
I'm very well, thank you. Very excited to hear you.
Yeah, this is my first DevLab, so thanks for having me. Really excited.
No worries. Same. Please
Cool.
tell us a bit about you.
Yeah, cool. So yeah, like you said, I'm a software engineer at Gearset, and I've been here almost 7 years. So yeah, we build Salesforce tools for DevOps tools for Salesforce. So yeah, I'll be telling you a little bit about our migrations towards React, and kind of telling you a little bit more about how we approach tech migrations in general. So yeah,
That's
I
great.
guess
Thank you.
I'll share my screen now. So hopefully you can all see that. So yeah, I'm going to talk about a migration to React, but also I'm going to talk in general about migrations and kind of how we approach those at Gearset. So I guess we've already talked a little bit about me, but yeah, I was involved in kind of quite a lot of the early growth of Gearset over the 7 years I've been here. And so I guess over the years, I've seen a lot of different migrations that we've gone through as part of our tech stack. So I want to kind of talk you through some of that. And like I said, Gearset builds DevOps tools for Salesforce, and that basically means that we make tools that the software engineer community kind of take for granted. Things like continuous integration, source control support, robust data backup. Things that we would take for granted as software engineers. Historically, Salesforce has been a little bit lacking in that tooling. So even though they're building things of the kind of complexity that would really benefit those tools, they haven't had those historically. So we're kind of there to fill that gap. But I'm here to talk about migrations. So this talks about a kind of one of the big migrations that we started reasonably recently at Gearset, and that was our move to using React for the front end of our app. But it's also about migrations in general. So I'll tell you about how we went off about kicking off that migration, and then we'll get into the weeds, and I'll show you some of the nuts and bolts of how we actually did it, and how it went. And then at the end, I'll loop back onto kind of what we can learn from the story, and I guess common struggles and common solutions I've seen across all of the migrations that we've done over the years at Gearset, and like the kind of, I guess, the philosophy that we apply to migrations. So yeah, if you have any questions as we go along, then please just drop them in the chat, and hopefully there'll be time to answer them at the end as well. But yeah, let's get started with our React migration story. So it's probably useful to have a little bit of context to start off with. So Gearset is a web app, and this is kind of a list of the technologies that power most of what we do. Obviously, it's not an exhaustive list, but these are the bread and butter of our tech stack. So we've got C# running on .NET Core for most of our backend. That runs on top of Kubernetes in AWS. We've got Postgres for most of our database needs, and then we've got ActiveMQ for managing queues to coordinate between different services. Let's zoom in a bit on that front end portion, though. So this is how things stood before the migration. The framework we're using for our front end is called Durandal, and if you haven't heard of it, I don't blame you. It's a pretty old framework at this point. It hasn't been actively developed for several years at this point. But in terms of how it works, it's a pretty thin wrapper around these three libraries, which you're much more likely to have heard of. So it uses Knockout for all of its data binding, and that's between the view models and the DOM. And on top of that, it uses require.js and jQuery to implement a kind of a component system so that you can have reusable chunks of functionality. So it has all of the core bits you'd expect from a front-end framework, including things like a router that loads the correct module when you go to a particular URL, all of that sort of stuff. But but really the whole thing is a very thin layer on top of these libraries. It leans pretty heavily on these lower level libraries. So here's a quick code sample, and don't worry about understanding all of this. It's just kind of the vague structure is really what I want to show you here. So this is the code for the component on the left here. It renders a dropdown, and at the top we've got a kind of a view model file with the code, and then at the bottom we've got the HTML view, and that HTML view references various properties in this view model. So the view model here is taking a context argument, and that's how you pass in properties from the parent component. So that's what you would think of as the props in React world. And this is how you would use the component. So in another view in the HTML, you use this widget data binding, and you tell it what widget you want, and then you tell it what values you want to pass through to that widget as the context argument. So yeah, the point is here, it's a front-end framework. They're all broadly the same, but slightly different. And in terms of how we actually ship that code to production, there's actually very little build. So we have some basic transpilation down to ES6, and that's just for browser compatibility. We have some linters for static analysis, basic code quality issues. But we have no real bundling, no real minification here. What you write in your code editor is very close to what's actually shipped to production. And a common reaction when I used to tell people all of this is basically, oh God, that sounds so legacy. Why haven't you upgraded yet? And I mean, yeah, this is a story about us doing that upgrade. So obviously there came a point where this wasn't working for us anymore. But I think there's also something to be said for old boring tech stacks. So I'm gonna do a very small defense of old boring tech stacks for a second. First and foremost, it works. And that's a big point in its favor, but obviously it's not sufficient on its own. You could justify never changing anything with that argument. But the fact that it's been in place for 5+ years, and occasionally it was an annoyance to be on an old tech stack, but rarely did we feel that as a development team we were held back from what we needed to work on and deliver. So that's in its favor. Secondly, there's not really many moving parts here. There's no build, there's no the libraries and frameworks that we're using, they're not changing under our feet really. They're mostly just getting security updates and small performance upgrades. So that lack of moving parts actually makes problems pretty rare and pretty easy to debug. Durandal itself, like I said, is a very small framework, and in fact the entirety of the business logic is in literally 15 JavaScript files, and a couple of those are chunky. They're 1,000 lines or so, but still, it's very feasible for a developer to have a good understanding of how it works in its entirety in a few hours of effort, which you can't say for every framework. Another thing keeping us from upgrading is we keep the front end pretty simple anyway. So as a general rule, we try to keep as much of our business logic in the back end as possible, and that means there's less benefit to upgrading to a new framework. And finally, there's also that risk of picking the wrong shiny thing to upgrade to. JavaScript frameworks haven't historically had, the best reputation for sticking around for the long haul. So, those are the things that held us back from upgrading. But, things change, and you have to revisit your assumptions. You have to revisit your conclusions. So what made us reevaluate? Well, yeah, it works, but over time things worked less and less well, and particularly as the app grew, we started to have performance issues on pages that had a lot of data to show, and we quickly traced that down to being basically down to Durandal's component system. It's a small library, but it's also not particularly smart about composition and updates to the DOM, especially on the page load. And we found that pages with too many components on them started to get very slow, even if those components were very simple. And that started to drive bad behavior, because we started to avoid splitting out components, even if we knew it would be a better structure, just to avoid the performance overhead, and that's not ideal. And then those bad habits had a sort of impact on how easy everything was to debug. So as the framework got older, fewer and fewer people were using it. It was harder to turn the community for any help with framework issues. All of these things kind of added up to It's not really that easy to debug anymore. Another problem was security updates. So when the project was finally put into maintenance mode, Durandal that is, we had to manually update the underlying libraries like Knockout and jQuery when security patches were made available for those. And although that was manageable because the framework was small, it was an overhead, and we were sort of drifting towards accidentally having an in-house forked custom front-end framework with all the downsides that that entails. I touched on this already, but our philosophy remains the same in terms of keeping the front end as thin as possible, but pushing our product forward started to put us in the position where we really wanted to build richer front-end experiences, things like graph views with drag and drop movement of nodes, faster interactive browsing of data sets, a bunch of other things. And those experiences were possible to build, but they were difficult to build, especially when we wanted to integrate new third-party libraries that maybe weren't designed to slot into the setup that we had. And that final risk of picking the wrong new shiny thing, that's always present. But the longer something's been around and the more popular it is, the more confidence you can usually have that it's going to have a large community for the foreseeable future. And React definitely felt like it was at that point in its adoption cycle. So really the summary is that all of these factors pushed us to where the return on investment was pretty clear. It was worth the risk, it was worth the migration overhead, and it was worth the increased complexity in return for a better developer experience, lower maintenance overhead, better code quality, and ultimately a better customer experience. So all of these things were kind of pushing us towards a migration. So at this point, we've decided to migrate, but we need a plan of attack. Skipped a slide there. So I spent a lot of time thinking about risk. A lot of the hard things in software engineering, I think, can be usefully framed in terms of managing risk. The risk of making the wrong decision, the risk of breaking everything, the risk of not understanding the full picture before we build something and building the wrong thing. So as a team lead, I think a lot about how to manage that risk for my team and how we can build the momentum and keep it up without risking giving our customers a bad experience when we get things wrong, because everything goes wrong all the time, and you have to plan for that. So what are the big risks here? Well, one is that we give our customers a bad experience. We don't want to stop delivering fixes, features, upgrades while we do this work. The world can't stop while we do this work. The second risk is that we don't finish the job. So if we get 80% of the way through and stop when we've done all the easy bits, then we end up with kind of the worst of both worlds forever. The third risk is that we tangle the code base in the process. So the goal here is to end up with a more maintainable code base and one that helps us move faster. So if we mangle everything in the name of finishing the migration, then we'll end up in a worse position than when we started. And finally, there's always that fear of breaking the entire world. So how do we mitigate all of these risks? Well, the main tools that I reach for when I'm thinking about something risky are these. First, you practice, and you make the practice as representative as possible, and you make sure the consequences of failure are low. Secondly, you make it routine. The more often you do something, the less scary it is. And thirdly, you iterate. So once you've made it routine, you can iterate on the process. Over time, your process will become battle tested, and it'll be better than you ever could have designed it. So the first three of those, I think, they're pretty universal. Think of deployments to production. That's a risky thing that we do as software engineers. How do we make those low risk? Well, we have a staging environment. So we practice each release in the staging environment, and it's as close as possible to the real world. We release often, and we make it routine. So 3 times a day or more if we can manage it. And then we iterate on that release process. If anything ever goes wrong during a release, we examine whether we can do anything to build the process so that thing can't go wrong again. Even if you think of something like airline safety, obviously very high stakes and many, many more elements there, but they still practice first. They fly a plane without passengers before they fly it with passengers if they've got a new type of plane. They do lots of tests on the individual components before they even build a plane. Flights are routine. They iterate on every accident and every near miss. And really, that's the main thing that's made modern air travel so surprisingly safe. So I think there's a lot of commonality between risk management in lots of different areas. The final point here, front loading the unknowns, is a little bit different. It's not about the risk of breaking things or blowing things up. It's about the risk of building the wrong thing based on incorrect assumptions. So by thinking about what assumptions we're making and what we're least sure about, we can explore whether those assumptions are correct right at the start, and then maybe we can save some time kind of going down dead ends based on those incorrect assumptions. So going back to our risks, how can we apply those strategies I just talked about? Well, really, there's one way that we can apply all of those strategies, and that's to do it a bit at a time, and importantly, to pick the right bits to do first. So we can front load the risk and practice by picking the right bits to start with. And as we do more and more chunks, the process will become routine and it'll become easy and low risk. So then the question becomes, how can we chunk it? We've already written off the all at once approach. Another approach might be maybe one page at a time. So essentially by doing this, you can silo the new world from the old world entirely. And each new page load might be on the old framework or it might be on the new framework, but the user ideally doesn't notice, and you can have a nice clean separation between your two stacks. Unfortunately, that doesn't really work for us because we have a single page app, and navigating to a new page doesn't actually reload the browser page. So we considered modifying our existing app so that it did reload the browser page, but that was tricky and it was a risky task in and of itself. So there's also a reason we don't reload the page on page changes, and that lets us build a snappier experience that doesn't reload everything every time you click a button. And like I said, one of the issues that we were having was performance, and we didn't want to make that worse. So what about one component at a time? So the idea here is that we find a way to mix and match React and Durandal components on the same page, and then we slowly replace the old ones with React ones. And you can do that a couple of ways. So you could go top down. So you could replace the top level app component with a React one, but keep everything inside that as legacy, and then slowly replace downwards until you have no legacy left. Or you can go bottom up. You could find a way to run React components inside the legacy ones and start replacing components in the tree from kind of the leaf nodes upwards. So what's easiest here? Well, it really depends on your kind of situation, but we decided on bottom up. That is replacing the leaf nodes first. There are a couple of reasons for that. Firstly, it's easy to run a React component as its own self-contained thing. You just need to give it a DOM container to run in. And secondly, our top level components, they'd end up with kind of quite a lot of state in them. And starting from the bottom actually starts with the lower hanging fruit. So you might think that runs counter to front loading the unknowns, but actually the opposite. So we can de-risk the fundamental risks. So things like, can we run these frameworks side by side? What does it actually look like in practice? Things that we actually don't know. Before we spend too much time worrying about problems that we know can be solved, like, okay, what's the best way to store our state once we're in this new React world? So going bottom up was actually de-risking the most important things first. It's worth saying here that we could have done a mix of top down and bottom up. We could have just kind of gone crazy and replaced things all over the place, but we decided to do strictly from the bottom up. And by that, I mean, we don't allow legacy components inside React components. And that's for three reasons. One is it's one less problem to solve. We only have to know how to run React inside Durandal, and we don't have to know how to do the opposite. Secondly, it gives us a clear separation between new world and old world. And thirdly, we have a clear sense of how much of the app is migrated. We can't kind of cheat by not migrating a tricky component and leaving it in the old framework. We know that once the top level node of every page is React, the entire app is React. It does have one downside, which is that we might have to maintain 2 copies of commonly used components and keep them kind of in sync behavior-wise during the migration. But that's kind of a double-edged sword. Yes, more overhead is bad, but also if it's annoying, it'll force us as devs to kind of just finish the migration to get rid of the headache. So, at least the incentives push us in roughly the right direction. Okay, so we have our plan. And now for the hard bit, which is making React and Durandal coexist. So what's actually hard here? Well, really, it's the interface between the two frameworks. So our first attempt is just to drop in the React components. And this is kind of what that looks like. So this is just a standard Durandal component. Everything at the top here is just a standard boilerplate for a Durandal component. There's something special happening here in the binding complete handler. So this function is called by Durandal once our component's DOM is fully loaded. And we've made sure to put a container in the DOM there where we can mount some React, which is selected by the selector. And then we just tell React DOM here to render our component in there. So that's pretty decent. And here's the React component. So this is just a normal React component that's pulled out of the React docs. There's one slightly different detail, which you might notice, which is that the module format here is AMD, which might be unfamiliar to you. For those of you who aren't aware, JavaScript's concept of modules has historically been a little bit all over the place. I'll give you a very quick primer, but trust me, there's dragons here. So in the good old days, JavaScript was basically for mouse cursor trails and drop-down navigation, and that was about it. And everything was global. And then a little while later, people thought, well, that's not really ideal for, for me. Everything can trample on everything else. But the only tool that they really had for making things private was a function closure. So we used functions which immediately executed themselves as a way to hide state from the global scope. Then a little while later, Node.js came along and they thought, well, we probably do need a real module format for this. And they invented CommonJS, which works pretty nicely. But unfortunately, it's completely synchronous, which means when you load a dependency, the world stops while you load and run it and all of its dependencies. And that's fine for server code, but it's maybe not so great for the browser. And then require.js comes along, and they said, look, we're sorting this mess out for the browser, and they invented asynchronous module definition, which is what you saw in the last slide. But you still had a problem of kind of knowing which of these things to use and getting compatibility between everything. So then ES modules came along, and that's an actual standard with native browser support that's supposed to solve a lot of problems, and maybe it will someday. And then UMD is kind of hanging out in the corner, and it's not really a format, but it's more of a way of writing modules so that people can read them as either CommonJS or AMD. So it's simple, right? So depending on your perspective, ES modules is either kind of the one true savior or it's yet another standard. Anyway, the important thing here is that it's been a mess, but maybe soon everything will be ES modules. I don't know. Anyway, why are you telling me about modules? Well, Durandal uses require.js. Require.js only works with AMD modules, and they're kind of the legacy format at this point. So yes, we can drop in our React components as AMD modules, but we started to run into a few problems with that. Firstly, third-party tooling gets quite confused, and that's mainly because it's a bit of an old format. And secondly, third-party components are no longer shipped in AMD in React world, and that makes them very hard to integrate in some cases. Finally, once we're done, even if we succeed, we'll kind of be left with all of our React components in an outdated module format. So maybe we'll have to do another migration to migrate everything out of the old module format, and that's not great either. So really, we decided we needed to revisit our minimal build, and we needed a way to mix and match module types. And the easiest way of getting that is to get ourselves a bundler. A bundler gives us a bunch of stuff. Most importantly, that mix and match ability, but it also will give us minification, build time errors for broken imports, loads of third-party plugins for doing loads of other stuff. So the most popular and well-supported bundler is Webpack. So we just drop it in, right? It's the default solution. It has a massive community. It has countless plugins. It's endlessly configurable. What can go wrong? Well, not so fast. We've just found the new hard bit. Webpack is a static bundler. What do I mean by that? Well, what I mean is that the dependency resolution is static. So it takes one or more entry points in your code, and then it analyzes at build time all of your imports. It follows them and it builds a tree of everything that's in your code. So for each of your imports, it parses it, it replaces it with some Webpack magic, and then at the end, once it's on the whole tree, it bundles everything together. That means it needs to know at build time how to follow every single one of your dependencies, which sounds reasonable enough, right? Well, it is reasonable, but it's not how Durandal works. So you'll remember that Durandal uses require.js to load its dependencies. But actually, it has a layer in front of this that lets you configure how the framework finds your component files. And that's a pretty handy feature, especially if you're loading your files over the network, because it allows you to configure the location of the files however you want. You can have all of your JavaScript over here, or all your HTML over here if you want. However, it causes problems for Webpack. It can't follow that custom arbitrary runtime routing, even if you're not actually using that functionality, and we weren't really using that functionality anyway. But still, Webpack was struggling. So there's only one thing for it. It's patch time. We looked into writing a custom loader or a plugin for Webpack. At the end of the day, it actually turned out to be much easier to just patch Durandal. So there's a few reasons for that. Firstly, once we've finished the migration, we can safely delete the workaround with 100% confidence, because we'll be deleting Durandal anyway. Secondly, Durandal is actually much easier to understand than Webpack. It's a much smaller framework. Thirdly, we're not using the custom module resolution anyway, so it should be reasonably straightforward to patch it out. And then finally, Durandal no longer gets any updates, so there's no risk of getting any upstream updates that will conflict with our patch that we'll have to sort out. So the main problem here is that if we're patching out the way that Durandal currently loads dependencies, we need to give it a replacement so that it can load the right thing at the right time. And at the same time, Webpack needs to be able to build a dependency tree of everything so that everything is included in the final output of the build. So there's a naive solution here. And the naive solution is to import every single component right at the top of our app. So the idea here is that we have a big file, and it's called widget registry. Widget is the name that Durandal uses for components. And Webpack can use that file to just load everything because it imports everything. And then we can use that file to load the dependencies at runtime inside Durandal. So when Durandal would previously have gone to the network to get a dependency, instead it can just go to this file and find it. So here's what that widget registry looks like. You can see that basically it's just a dictionary, and the key in the dictionary is the name of the widget that you would have given to Durandal anyway. And then the values in the dictionary are just the imported modules. So that's pretty easy. And then here is one element of the Durandal patch. This is the part that actually modifies how we resolve these modules. There's a lot here that's very Durandal specific, so don't worry about the details too much. Right at the top here, we're importing system. And that's kind of the main Durandal object that does most of the Durandal heavy lifting. What we're doing here is we're actually replacing system.acquire, which is the function in Durandal that does the module resolution whenever a module has to be loaded, and that includes things like widgets. So before we patched this, acquire would take a module ID, so that's that widget ID string, for example. And what it would basically do is it would run it through that custom resolution stuff that I talked about, and then it would go to require.js and tell it to load a file, and then it would return basically an instantiated version of whatever that request returned. So instead of that, what we're doing here, and it returns things kind of with using all this kind of Durandal async guff. So just trying to ignore that a little bit. These dfd.resolve statements are our return statements. So here what we're doing, instead of taking a string, we're actually allowing this function to take an instantiated module instead. So we're detecting when that argument is maybe a function or just an object. If it's a function, we assume that it's a constructor for a module, and we new it up, and then we return it. And if it's already an object, then we assume that it's kind of an instantiated module already, so we just return it directly. So conceptually, this is actually pretty simple despite all of this noise. And then here is how these modules actually get through to the resolution function. So this is patching the widget code within Durandal. So this widget function that we're patching here used to just return a module ID, which is the string that would get passed into the thing that we were just looking at. We've patched that so that instead of that, it actually just goes to the widget registry and it looks up the actual widget implementation and it just returns that. So that's how we actually get those instantiated modules down into the system.acquire. And that's actually most of what we had to do. So there's one other main bit I haven't shown you, which is the dependency between the view model files and their corresponding HTML view files. That also had to be made explicit, but that's basically more of the same sort of stuff. So I'm going to skip over it. So that's surprisingly easy, and it actually does work. The app loads, which was a surprise to me. But there's some downsides to this approach. Firstly, we're lying to Webpack. It doesn't know the true dependency tree here, and that means it won't be able to split the final code bundle up if we want it to. So we'll have to load all of the code on first load. Excuse me. The second problem is that we have to have these big lists of components. So we're going to have to build them, and then we're going to have to update them whenever the list changes, for example, when we add a new widget. But both of those are actually pretty acceptable because they're both temporary while we do the migration. And it's easy to automate building the big list. Hopefully we'll never actually add to the list because we'll only slowly delete stuff from it as we migrate to React. My biggest concern here was the performance of having to load our entire front-end code base on page load, no matter which page you're on. We said at the start that one of our main objectives was not to give our customers a worse experience during the migration. So I don't know about you, but my gut said that this was a bad idea. First load times will be way, way slower. But I've had enough run-ins with kind of premature optimization to know that you should always validate your hypothesis when it comes to performance. So I ran some numbers, and I was actually sort of surprised. So before the change, on the first page load, in total, there was 1.1 megabytes of JavaScript being loaded over the network. And afterwards, we did manage to split out a few third-party libraries as separate bundles, but apart from that, our entire front-end code base is now being loaded all at once. So this bar on the right is all of our code all at once. And the result is a bundle size of about 1.3 megabytes. So how can that be? Well, really, this is a lesson of the power of gzip. Previously, we were loading each component as a separate network request, and that meant that each kind of had its own compression applied. However, when we bundle everything together, we can compress the whole thing as one. And it turns out that the savings when you do that are enormous. Think of how many times your front-end code base defines a class or imports something, or 1,000 other bits of boilerplate. So combine it all, and suddenly your code base becomes extremely compressible, even after you've minified it. And it's worth saying that obviously afterwards we've also got minification turned on, so that helps as well. There's some hidden extra overhead here, though. Size isn't everything. The browser's still going to have to do a lot of more work here because it's going to have to load and parse our entire code base, that entire bundle. And there's a lot more meaningful content here afterwards. We found in practice that was actually balanced by another saving, which is that you don't have to load your dependencies in sequence anymore, because before you'd have to load one component to even find out what its dependencies are. So there was a whole kind of network round trip on every layer of dependencies. So by eliminating that, we actually save a lot of time. So actually in practice, this is what we went to production with. It's a little bit finger in the air because of the kind of the trade-offs between slow networks and slow computers. But in aggregate, we found that after we released the switchover in our telemetry, first page loads for real customers they were pretty much unchanged. And that was on pretty much any metric we looked at, but particularly we were looking at time to first interactivity. And all subsequent page loads after this are actually much faster because there's no network request at all to initialize new components. So that's actually pretty nice. And at this point, you might be forgiven for complaining that you thought this talk was about React, and don't worry, it is. Now we've got Webpack, we've kind of solved all our problems, and now it's really easy to drop in new React components at the leaf nodes. So going back to our previous example, This is when we just dropped React in. This is still an AMD module, but Webpack doesn't actually mind because it's being imported statically, not dynamically. And the difference now is that the React component itself can be in whatever format we want. And we can import any third-party components as well that are in any format. Just as a side note, we actually decided just after this to convert everything into ES modules format in one sweep anyway. So if you see that in future slides, that's why. All you really need to know is that the module format doesn't matter anymore. So the hard part here that we ran into quite quickly is managing state across the framework boundary. So React out of the box uses props to pass values down to children, and it uses hooks for state and side effects. Durandal uses knockout, which has kind of the slightly different concepts of computeds and observables. So here's two examples of kind of basically almost the same component, one in React and one in knockout. The point here is that they're quite similar. So React is a little bit more magical. Here we've got a prop with first name that's being passed as a prop, and then we've got a piece of state for a last name, and then we're just rendering the combined output here. And React will automatically re-render this whenever last name changes or whenever first name changes. And here in knockout land, we've got these two observables. These are basically just values, but they're values that you can subscribe to the updates to. You've then got this computed, which outputs that first name, last name combo. And the special thing about computed is that any observables that you access during computation of the value, the computed will actually automatically update whenever any of these are updated. So these are acting in a pretty similar way. So if we've got, for example, observables in a parent component, and we want to pass those down as props to a child React component, what do? Well, this is a naive approach. We've just passed the observable straight in, and the way of reading the value of an observable is to call it like a function. So this seems like it would work. Well, it will work on first load, but unfortunately, if the observable changes, React doesn't know to re-render this. So if the value inside here ever changes, React will not re-render. If a render happens to run for a different reason, it will update. So you might think that it's working, but it will be buggy in some situations. So that's not ideal. So to fix this, you have to actually subscribe to the observable, and you have to have your own local state, which gets updated whenever that value changes. And this will actually trigger React to re-render whenever this value changes. And that works, but it's pretty clunky, and it's also very easy to get wrong. So the first step we took was actually to create a custom use observable hook. So this is a hook that we wrote. And you give it an observable, and it gives you back something that acts like a normal piece of React state. So this is much cleaner, and it's also much harder to get wrong. But we still have a problem here, and that's that our React component knows about knockout stuff. So it's being passed observables, and it's doing stuff with the observables. So the boundary here is pretty blurry. This is just a toy example, but imagine a component with lots of props like this. What happens when you get around to upgrading the parent component? Well, you're going to have to update all of the child components to use normal props instead of these observable props. And that could be a problem. Are you forced to upgrade all of the parents at the same time if one child is used by a lot of parents? There's all sorts of problems there. So the solution to that problem is to insulate the new child component with a wrapper, and the wrapper deals with the interface between the two frameworks, and then the child is that first React component that we had. It doesn't know anything about knockout. So that way, when you update the parent component, you just throw away the wrapper, and the only thing that the wrapper needs to deal with is the translation. But what's happening in the parent component? So this is this is the same thing that we had in the last slide, but this top component is how you would use it in a parent. So when we attach the component, we call React DOM to actually render the thing. But we also have to remember to detach and unmount the component when our parent detaches. So this is a lot of boilerplate, and it's, again, easy to do wrong. So again, we made another utility. So mount React component here is another function that we wrote, and it takes the parent Durandal component. It takes some selector so that it knows where to put your new React component inside it. And then you just give it a function that renders your React component. The magic here is that we don't need the wrapper component either. So not only have we got rid of all that boilerplate from the last slide, we've also got rid of the wrapper component, because mount React component knows how to subscribe to any observables that you pass it. So it's basically dealing in the background with all of those edge cases that we've come across. So it makes it so easy to do the right thing, and it makes it quite hard and inconvenient to do the wrong thing, which is exactly where you want the incentives to be. So now, at this point, finally, the risk of things going wrong is much, much lower than it was before. So now we can involve the whole engineering team, and we can tell them to go crazy. There's one final piece of the puzzle. So the team knows that there's a React migration going on, but maybe some people don't know what a good component actually looks like. So some of our developers had used React before, some hadn't. Even the ones that had, there's a whole spectrum of styles and philosophies when it comes to how to use it. So it's quite important for us to have good communication around all of those questions, and so sort of make sure that everyone's pulling in the same direction. So note that some of the questions on this slide, they're not questions that we were necessarily confident to answer definitively when we first looked at them, but we kind of iterated over time. So it's important not only to have guidelines, but to be open to revising those guidelines constantly as you learn. So our documentation on these topics has evolved over time, and it will continue to. And those solutions that I showed you, those utilities that make it easy to do the right thing, those also evolved over time. They weren't the first iteration of what we did. So now that everyone knows what they're doing, we have a target for what our new code looks like. We just need to make sure that we finish the job. So new components have to be in React. That's the first rule that we implemented. And for a while, we only had that rule. That allowed us to kind of keep momentum up on shipping new features while slowly kind of building up a little bit of institutional knowledge across the team for how to use all those patterns on the previous slide. And so it kept the risk reasonably low while we were all learning how to navigate this new world. And at this point, we're now pushing ahead with the second rule. So the second rule is, if you touch a legacy Durandal component, convert it to React if you can. But if it's really not practical to do it in one go, then at least get us one step closer if it's not practical. So maybe that's upgrading one of the child components so that we're one step closer to having all of the children be React. Eventually, we'll probably have to add some third rule aimed at kind of mopping up the long tail of rarely touched components, but we're not there yet, and we're still kind of having good progress with both of these rules. So really, we're pretty happy at this point. It went pretty well so far. I'm kind of confident that it will continue to, touch wood. So what can we learn? What are the generics here? Well, this isn't the first time we've done a migration in our tech stack. Here's an example of all of the ones that I could think of off the top of my head, and there's probably a lot more. So you might notice that we migrate towards Postgres a lot, and that's probably a story for another time. The ones down at the bottom are in kind of various states of progress, from kind of well underway to just getting started. And the vast majority of these went very smoothly. The few that didn't, they still had clear rollback plans. So when things went wrong, we just rolled it back and we got it right eventually. So what are the common threads? What do all the best migrations have in common? Well, number one, I think, is that we always do the smallest change we can in each increment. So if something goes wrong, hopefully it's just something small. And this is actually something that we apply across our entire engineering department on everything that we do. So when we're shipping a new feature, we also try and slice it into the smallest useful chunk that we can actually deliver. And that's because the smaller the step, the smaller the explosion if things go wrong. But it also means that we can course correct if we see things, decisions that we've made that perhaps aren't the correct decision. We can course correct those early on rather than waiting until we've done loads of work before realizing that we've done something that wasn't ideal. Number two is that we always have a rollback plan. Something always goes wrong, so plan for it. Most of this is actually handled by our blue-green release process. So 99% of the time, we don't really have to think about it, and we can one-click instantly switch back to an old, like known good version of the code, and our customers don't notice that anything went wrong. Sometimes that's a little bit harder, and we have to think about it a little bit more because it involves data migrations, but it's still possible, and it's something that we make sure we always do. Number 3, like I said, we front load the risk, and that means doing the refactors up front. We make the change easy, and then we make the easy change. I think that's a Kent Beck quote, but anyway, it's a good quote. So that's why we spent half an hour talking about Webpack today. Number 4 is that we establish the patterns and the rules. So everyone needs to be bought in to make this happen. So make it easy for them. Establish patterns, make sure they're kind of clear on what's happening, and be open to amending those patterns and those rules if it makes sense to, and if they're telling you that they need to be changed. In the same vein, it needs to be simple to drop in the new tech. So making the interface low friction, using patterns and adapters makes it easy to do the right thing and hard to do the wrong thing. It's also really important to keep that boundary clear between the new world and the old world. So in particular, the new world should know as little as possible about the old world. And that way, when you're finished, you make sure that you've actually purged all of the downsides of the old system that you're trying to get rid of. And then one final point, number 6, make it easy to see how much of the job is done. So that'll make it so much easier to finish the job at the end. If you can't see where you are, it's easy to get demotivated and kind of lose steam. But if you can see progress, you can keep the momentum up. I've actually heard that Spotify take this one step further, and they give each team kind of a percentage done for each migration they're doing, so that they can have some kind of healthy competition between teams. And that's a pretty interesting idea that we haven't really tried. But yeah, if your teams have kind of clear boundaries of code ownership, I think it could work. We don't really have those kind of clear boundaries of this code is owned by this specific team. Maybe we will do in the future, and we can apply this kind of idea. So yeah, thanks very much. That's pretty much all I wanted to talk about. So if you have questions, then I'm happy to answer them if there's time to do so.
Thank you so much, Oli. That was great. I was always told that React helps you work smarter, not harder. So thank you for the presentation. It was very helpful and insightful. I will now jump to the questions from the audience. So what libraries and frameworks are you currently using at Gearset?
Yeah, so I guess I've gone through a few of them. So currently, the main bulk is in Durandal. That's kind of switching over. We're probably half and half now through our migration. So we're moving towards React. In terms of other tech for the front end, we're just kind of in the early stages of looking at moving most of our state over to Redux. Well, that's in quite early stages. We've also started integrating TypeScript because that works really nicely with React. We've got various other kind of smaller components that we use for things like table visualizations and graph visualizations. But yeah, those are the ones I've mentioned are kind of the really big ones, at least for the front end.
Okay, and then why did you choose React over other frameworks like Angular?
Yeah, it's a good question. Really, we were looking for mainly something that could handle all of the things that we wanted to throw at it. And to be honest, if you take any modern framework, you're going to come up with a pretty good solution. And then secondly, we wanted something that would be sustainable for the long term, because these kind of migrations, they take a lot of work and they're sometimes painful. So we kind of wanted to pick something that would be supported for the longest amount of time. And it felt at the time when we made the decision that, on balance, React was the way to go. There's also a few other factors, like more of our team had experience with React than with other frameworks like Angular, and having some experience already helps if there's not that much to pick between two different frameworks. So it was a kind of a combination of those things.
Okay. So how was your experience convincing the team to step towards migrating to React?
Yeah, it's a good question. I would say there was a mix of opinions, but broadly, by the time that we made the decision, everyone could see that we needed to migrate from what we were currently using. I would say that Gearset's a very sort of pragmatic engineering culture in terms of how we pick our tech. And I think all of the engineers are kind of bought into that. So really, we only upgrade when we see a clear need to, and when we think it'll get us a real benefit. And I think there was kind of agreement broadly across the team that upgrading to React would be a clear benefit. So really, there wasn't that much convincing needed. I guess the other place we might have needed to convince people would be to kind of convince kind of the higher ups that that we needed to spend all of this time actually doing the migration. But again, I think we're a very pragmatic engineering led organization, and there's not really much question that if the engineering department decides that they need to spend some time improving the tech and making sure that we've got kind of a sustainable code base for the long term, not really a problem at Gearset. So yeah, I would say it was pretty easy, and I think that I put that mostly down to our culture at Gearset.
I like that. I like that. Thank you for sharing. So I know that a lot of people who are watching the Dev Lab now, they're just starting their tech career. And I know typically people are expected to have a basic knowledge of programming fundamentals when it comes to starting in tech. But what first languages would you recommend learning for someone with no tech experience?
Um, you get asked this a lot by kind of friends and family and things like that. And my answer is always, it really doesn't matter. I think it's more important to get, I guess, to get hooked, because that's, I think, every really good software engineer that I know just got hooked on something at some point, and I don't think there's really much commonality between what they got hooked on. So I got hooked building Flash animations and silly little games, and then I got hooked building websites in PHP. And I think, to be honest, most of the things that you can learn in any language, you can then apply across different languages. I think JavaScript's always a good bet, because you can kind of make something that's easy to share, and that's easy to kind of get yourself motivated, because you can share a cool thing that you built, and just share a link to someone, and they can say, they can look at it and get excited with you. So
Absolutely.
for me, it's more about what you can get excited about. If you're really excited about Python, go do Python. If you're really excited about JavaScript, go do JavaScript. If you're really excited about backend infrastructure technologies and databases, go do that. Like it doesn't
Yeah.
matter. Just get
Totally
excited.
agree. It's all about passion.
Yeah.
Going back a bit to React, are updates on React easy, and do you do them?
I guess there's two ways you could look at that question. You could look at it as in terms of upgrades to the React framework itself. So yes, those are pretty easy. The React team are very good at keeping backwards compatibility. So there's very rarely anything that breaks when you upgrade React itself. So yeah, I haven't really found any problems there. I guess they do occasionally introduce new concepts, like hooks, for example. So there's a bit of overhead there in terms of working out whether you want to use the new features or whether you don't want to use the new features, and kind of what your internal culture is in terms of how standardized you want the code base to be, whether you want everyone to be using a different style and doing whatever they want, or whether you want to say, we use hooks, we don't use class-based components, things like that. So I guess we're kind of in the middle ground there. So yeah, I would say that the upgrades themselves are easy. The decisions about which parts of the framework to actually use, perhaps more dependent on the team and the culture.
Okay, perfect. Thank you. And how do you assess usability, and has your methodology for this changed over time?
Yeah. So I guess I would say that possibly there's more that we could do here. So obviously, lots of us are front end developers, and we're sort of aware of all of the best practices when it comes to kind of usability and accessibility and all of those things. And we've got an absolutely fantastic UX team, and basically we trust them to make sure that we're building a really good usable product. I would say in terms of kind of fixed methodology, there's not so much there. What our philosophy here is really to be as close to the users as possible, and to talk to them pretty much every day. So even as engineers, I talk to customers almost every day, and we really encourage that from our engineering culture. So it's much less of a problem when you're talking to users every day, because they will complain about usability issues. They will say, I don't understand this. What does this button do? Why is this button disabled? All of that stuff. So I think the fact that we don't have a really strict methodology there is a result of not having needed one yet as we've scaled the company. Maybe as we scale the company even further, we'll need more structure there. But right now, just talking to our users relentlessly is really the approach that we have on all of this type of stuff, and that's worked really well for us so far. So yeah.
Okay, last question. Have you found migrating over to React has made it easier for workflow and better front-end designs?
Yes, I think yes, we're already seeing those benefits, but I think it's also early days to see whether that does pan out. I think I'm pretty confident that it will be. In particular, it's so easy already to kind of integrate all of the latest, shiniest third-party components, and some of those have you can just drop them in, and it saves you so much time. And someone else has already thought about all of the best ways to implement a particular feature. So we use a third-party library, for example, for our graph visualizations, and we've done a lot of work on top of that to kind of customize it to our needs. But there's a lot of work that's been done for us under the hood there, and React really was kind of a prerequisite for using those types of libraries, because all those modern libraries are in React or some other front-end framework these days. So yes, it's helping, but I think we're still kind of waiting to get the full benefit once we've actually completely finished the migration. So yes and no.
Okay, thank you for sharing. Thank you so much. I loved the presentation. It went by so fast. So thank you.